Let's slowly start into it. I think we're just in time here anyway, even if some people are still finding a seat. So a warm welcome from my side to the Spring Framework 5 talk this afternoon here at DevOps UK. It's actually my first appearance at DevOps UK. Shame on me. I've been to so many DevOpses before, but it's the first time to the London edition. So in like a loose sequence of Spring-related talks today, this is a quite core-oriented talk. It is a personal selection of highlights and favorites in the Spring Framework 5.0 generation, with a few forward notes on 5.1 sneaking in. It is basically part of my everyday work, what I'm presenting here. I'm already in the 15th year of my role as the Spring Framework project lead, literally as in the Spring-Framework project in the GitHub organization for Spring projects, the core framework with everything that it brings. So we're going to do some web stuff today. We're going to look at some web API design, core framework design for web purposes, everything that the core framework brings with it. And I'll have a few notes on Spring Boot, but it's not the focus of this talk. All right, the hidden gems part, as we can get to it towards the end of the talk, I'm going to take you on a quick tour through some stuff that we don't talk about as often as we should. Basically, the rest of the best. Everything else that we're doing. We always talk about feature themes, in particular in Spring Framework 5. That is very much the case. And there's always the little things that come with every release. And there are quite a few little things at the very end of this talk. All right. So this is basically the fact sheet. Spring Framework 5 is already out for a while, 5.0. We are working towards 5.1 at this point for a release candidate in early July and GA in early September. The 5.0 release was not a coincidence, came very, very closely attached to the JDK 9 GA release. It's finally JDK 8 baselined, a great benefit for us and actually showing through in this presentation a few times, where core framework APIs can now make the best possible use of Java 8 language and library features. And of course, JDK 9 is only the beginning of a commitment, right? We are tracking JDK 10. We've already had early measures towards JDK 11 support. And Spring Framework 5.1 in early September this year is no coincidence either. JDK 11 GA is coming our way in September, and it's the next long-term support branch of the core JDK. Right, so there's many other things worth noting here, but not the focus of the talk really. It's Java EE 7 baselined, basically, Servlet 3.1 Plus, and so forth. But it's also already covering the Java EE 8 API level. So Servlet 4.0, JPA 2.2, and this sort of stuff already coming in the Spring Framework 5.0 release. Not too much planned in the immediate future, not for 5.1 at least, because Java EE is currently in transition to Jakarta EE at the Eclipse Foundation. And we're waiting for the point where technical work can begin again, but it's not quite here yet. All right. So let me start with a few minutes on component styles. In our terminology, we're talking about the variants of our programming model, of our configuration model. There's, of course, the traditional style that most of you, I suppose, have seen before. Annotation-based components in Spring's annotation-based component model with like stereotype annotations on top and indications also expressed through annotations such as at lazy. There's the constructor injection indicated here by an at auto-wide annotation at the constructor level, and transactional as a typical indicator of a service triggering, a service level annotation, in this case, triggering the creation of a proxy or some form of weaving for a transaction begin and a transaction commit or rollback around this method. This has been fine-tuned for a long time. Much of this model is already in place for several years. We had a strong focus on refining this model in Spring Framework 4, 4.1, 4.2, 4.3 in particular. Very rich releases that brought lots of refinements little refinements for this particular variant of the programming model. For example, the commented out part here, using a single constructor for injection purposes, even if it's not annotated, is actually a folder 3 convenience feature for specific scenarios. The composable annotation model has been a particularly unique part of Spring, where you can always craft your own annotations, combining several Spring annotations into an annotation type of your own, and then declaring that annotation type of your own, meaning the combination of characteristics above. This is a Spring Framework 4 feature theme as well. Lots of it actually came in folder 2 and folder 3, to the full power, to all the nuances of it. So every time you're saying at my service here, you really mean this combination above, even if you have many, many components, many classes that need to be annotated with those combined characteristics. So the annotation-based model has many specifics that I see as unique to Spring. One of them is also the configuration class model, of course, well known not only from Spring Framework itself, but from Spring Boot in particular. So basically, Spring Boot is configuration classes on steroids. It really squeezes everything possible out of this model, including all of its @enable annotations, including the conditional part of it, which is indicated here through profile-based activation of certain configuration classes. Spring Boot really means this, right? Builds on the core framework facilities here in order to arrive at its auto-configuration model. It's essentially a factory method model. So in the annotation-based world, if you have slightly more complex rules for instantiating a class, for arriving at an instance of a particular bean, this is the easiest way out. An @bean annotation on a factory method, whenever the container needs a new instance of the bean, it dispatches reflectively to this factory method. The container is in charge of the lifecycle, so it actually triggers the instantiation for a singleton at a time when it sees fit, maybe a lazy init singleton. For a prototype or for a scoped bean, there may be many, many invocations of such a factory method. So last but not least, in the annotation-based model, and we're going to see variants of this in some other form in just a few minutes, this is the annotation-based model. Well established, actually at folder 3 level here. There are a few annotations here that are reasonably recent, like get mapping and post mapping have only been introduced in folder 3. The standard annotation is actually called @request mapping. These are what we call pre-composed annotations. It's basically composable annotations in action. You could create such custom annotations yourself, but for common scenarios where we had lots of feedback on, we decided to bring some of those pre-composed annotations, convenience annotations, into folder 3. And those turn out to be very popular. So you could also say request mapping for this path method equals get. It would express the same rules. This is just a little more convenient by baking the HTTP method name into the name of the annotation itself. All right. In Spring Framework 5, we chose to use a different perspective, or I should rather say, we put ourselves into a different perspective. Kind of what if the framework was to be used without any use of annotations, without class path scanning usually, without any use of reflection in its most extreme form? What would this mean, in particular to the core container, but also to a typical programmatic usage model? A programmatic usage model, not of the traditional kind. We have a pretty traditional metadata-based model, which is basically what all the integrators are using. This is still in place, has been the same model for 15 years, called bean definitions, the bean definition meta model. This is not really what we're talking about here. It's a first-class, user-level configuration model for smaller services, smaller deployment units. Think about microservice architectures, just a few components to be registered, a few endpoint classes to be registered, a little bit of auto-configuration, and you're done. So in Spring Framework 5, we chose this rather extreme position. This is an extreme position. We're not actually suggesting that you should try to get rid of any reflection at runtime. It is more of a challenge towards our own framework, towards our own core container and core abstractions. Is this even technically possible? And what does it mean to the core container to make it possible? The annotation-based model, by the way, has never been a part of the core container. Historically, the annotation-based model has only been introduced in later Spring Framework versions, not in the initial Spring Framework release, so the core Spring container was always programmatic. And we're making some really good use of these quite old core container abstractions here in a programmatic registration model now. So we're making use of our own isolation of annotation support into a dedicated support layer. It was never in the core container, which is actually quite important for what we're doing here. So, of course, Spring Framework 5 means we can explore Java 8. If we say functional registration, functional style, what we really mean is functional as in Java 8 functional, as in Java util function, Java util streams, lambda expressions, method references. That's the sort of functional that we mean, no more than that. And we also mean functional as in Kotlin. Somewhere in the middle of the Spring Framework 5 release phase, milestone phase, we chose to put equal focus on the Kotlin language. First-class support for Kotlin, not only at the core container level, all across the framework. We'll get to that in just a moment. So what does this mean in all applicable brevity? Programmatic registration can be as simple as this. Generic application context is actually a quite old class in Spring. Instantiating it allows you to programmatically register any bean definitions. But there's also nice new register bean overloads now. And those register bean overloads are really meant as a convenience for typical registration scenarios. You could just pass in a class, but that's kind of boring. The more interesting part comes here. There's a new notion called an instant supplier. It's basically a callback interface, literally a Java util function supplier. And registering a bean of a particular component type with an instant supplier, typically an inline lambda expression here, is basically the equivalent of an add-bean method, of a factory method, expressed in a different way. So this instant supply is going to be called by the container every time a new instance is needed. So for a singleton lifecycle, the container is in charge of when this happens, only once usually, of course. For a scoped bean or a prototype bean, this may be invoked many times. So whenever we need a new instance of bar, this instance supply is going to kick in, and for the construction of bar, we need references to other components from the container, we just call back to the container. Literally, context get bean or any other retrieval variants will programmatically hand you the references you're trying to inject. Still lazily referencing them, the equivalent of basically arguments, method parameters on add-bean methods. There's a slightly twisted variant below, right? A different variant below. Doing the same thing, but slightly more specific. For a start, here's a variant that has what we call bean definition customizers. Not one inline lambda expressions, but two. There's the instant supplier expression, and there's any number of bean definition customizers. It's actually a var arg. So this BD set lazy init call is a typical inline bean definition customizer. You can do anything you want against the underlying metadata model. Adding qualifiers, changing the lazy init flag, for example, are typical cases. Stuff you would otherwise do with add lazy or add qualifier annotations. So this is actually pretty convenient and sort of in line with the functional API design conventions established in Java 8. There's no reflection involved here in this scenario because any dispatch to the instance supplier goes straight, it's a straight programmatic invocation, right? So there's no immediate relationship to reflection here. Admittedly, here we're technically using reflection because class new instance, which we're actually not using anymore, but class new instance is technically reflection. If you'd like to get rid of this, this is a way out. Specifying an instance supplier as a Java 8 method reference that says, whenever you need a new instance of foo, here's the method reference to the default constructor or to a particular constructor on foo, right? So this is actually not reflection. It's an invoked dynamic dispatch straight to the default constructor of foo. So you can take this pretty far if you like. And the equivalent in Kotlin, and just we have to kind of keep it short here, but Kotlin actually has plenty of nice little things showing up in Spring here. The equivalent in Kotlin here, it's the same code, makes use of Kotlin extensions. In Spring Framework 5, out of the box, most of the jars have Kotlin extensions. So using the Kotlin extension model, like in this case, literally a generic application context extensions.kt file that comes in the Spring context artifact. It's ignored by the Java compiler, but whenever the Kotlin compiler sees it, you actually see an enriched, spiced-up version of generic application context with extra overloaded methods, basically, with extra methods attached that are only visible to the Kotlin compiler and that have Kotlin-specific signatures. So in this case, this looks like the Java code before, but this is actually a reference to a Kotlin K class, and this is a reference to a Kotlin K function in the signatures. The usage model is very similar, but it's as idiomatic as it can be for Kotlin purposes. So you don't have to do any kind of class.java little backing out. You're using Kotlin, you're using Spring from Kotlin like it was a Kotlin-oriented framework, even if it's internally totally Java-focused and built in Java. There's also a nice benefit coming up here. If you compare it to the version here, you had to specify the component class and the instance supplier. This variant here has just an instance supplier, technically a Kotlin function serving as an instance supplier. Because in the Kotlin world, the Kotlin compiler actually retains additional meta information for Kotlin functions, whereas for Lambda expressions and method references, there is no clean way to determine the return type at runtime. So you have to repeat it. You have to say bar.class, here's an instance supply for it. In Kotlin, we have a reliable way of figuring out what the return type of this Kotlin function is through Kotlin-specific reflection APIs for Kotlin functions. We're making use of this, avoiding your repeating of bar.class in any form here. And this is actually a pure function. It actually calls back to the context. The context is passed into the Kotlin function as the default argument. That's why it's called it. You could also refer to the outside reference of CTX if you preferred. This is what I'm dubbing the Java style. These are non-official names, right? So take them with a grain of salt. This I'm calling Gradle style because it feels a little like the Gradle DSL, the Kotlin DSL for the Gradle build tool uses similar Kotlin language features. It's basically the same code, but it's using the nested calls, and it's using the parameterization of types in Kotlin, which is also inferable at runtime in contrast to Java. So it's essentially a syntactic variant of the above, slightly different in how you express yourself in Kotlin. It's calling the same methods underneath the covers. We have just one generic application context, one Spring context jar, one set of Kotlin extensions in there, allowing Kotlin language features as shown here to interact with the core framework API, delivering these kinds of styles as a kind of natural outcome of the combination. All right, so much for a kind of API styles, component styles. In practice, of course, we know that many Spring Framework applications are really large code bases, so there's lots of shades of gray in between. You may, of course, mix and match annotation-based components, functionally registered classes, component scanning, proxy-driven at transactional, service boundaries with functional registration. You can mix and match at any level, as you always can in Spring. We are presenting it as an annotation-based component model, as a perspective, and as a functional registration model as a perspective, but it really is just a bunch of features, a large toolbox. You're free to mix and match, pick as you choose. All right, let's move on to reactive architectures. This is, of course, the main topic, the typically covered topic when we talk about Spring Framework 5. The Reactive Streams initiative, it was actually a really important trigger for us because it really presented us with a core abstraction for the interaction between runtime pieces, runtime infrastructure like runtime HTTP servers, web frameworks, data store drivers. All of those pieces have a way of interacting with each other through reactive streams here, interacting with each other in a non-blocking fashion. Reactive streams is basically a very low-level, very minimal abstraction used underneath the covers, usually not surfacing directly to your code. It's what the RxJavas and Project Reactors and Docker Streams of this world use underneath the covers to interact with, say, the reactive Couchbase driver or any other reactive data store driver you may use, and with a runtime web framework that kind of connects the dots here. The idea behind reactive streams is very simple. It's a publisher-subscriber model. The subscriber is in charge. The publisher doesn't actually pump any data to the subscriber unless the subscriber asks for the next few elements. Only when the subscriber is ready to process them, the publisher is going to produce them as needed. So there's never an overload from the publisher to the subscriber. The publisher could be the result of a database query. The subscriber could be the HTTP response stream. Both of them could be blocked by network issues, right? So having a non-blocking interaction model here is very, very important, in particular for unusual scenarios, high-load scenarios, scenarios with very uneven load, where some parts of your code could otherwise block for a quite long time. So the publisher doesn't actually publish any data to the subscriber if the subscriber is not asking for it, which is also kind of a lazy resolution model, right? The publisher is kind of a set of rules for arriving at an outcome, at an element. It's only actually going through the actual work as needed, as the subscriber is ready to process it, as the subscriber is even still active, right? HTTP responses can be cancelled. The publisher won't actually produce any further elements at that point. We turned this into what we call Spring WebFlux. This is essentially one of the two web stacks in a slight simplification of the actual arrangement. We have two web stacks in Spring Framework 5. A traditional servlet API-based stack called Spring Web MVC. The traditional Spring Web MVC module based on the servlet API leaking through. Being based on blocking I/O, right? The servlet model. A request comes in, you basically own the request. You assign a thread to you get a thread assigned to the request. We dispatch to your code. You own the request at that point. You own the thread at that point. You keep processing the request, keep producing the response until you're done, all in the same thread. And then you let go. The servlet model usually has a thread pool with like 150 or 200 threads at least in the background. Because, of course, there's blocking involved. Every time you're doing JDBC access, JPA access, you're blocking, right? So you really have to have quite a large number of threads, each of them being able to wait for the outcome of a particular request. And there's a risk of exhausting the thread pool, right? What if all the threads are busy? There are ways out with extra threads, but at some point, servlet containers are going to start rejecting requests. If every single one of those threads in the servlet containers thread pool is busy, you can't even accept the simplest index HTML call to your backend service anymore. So the servlet API is actually perfectly fine for many purposes, in particular if you're interacting with blocking data store APIs. And we keep supporting this as a first-class option, to be very clear about this. If you have an existing Spring Web MVC-based application, here's a natural upgrade part on the left side of the screen. Right? Just change the version number in your POMs to 5.0.6 at this point. If you start a new application, you got a choice of two now. You can choose to use the servlet API-based model, and we'll get to why you would want to do this, or you can choose to use what we call WebFlux, which is the other web stack. Very similarly aligned, strong Spring-style component model, design nature to it, but it's actually based on a totally different abstraction, on an abstraction of our own, based on reactive streams, integrating with Project Reactor, which is kind of a tightened-up version of RxJava, and using non-blocking I/O. Non-blocking I/O against NetT as the most powerful network infrastructure we have in the JVM landscape, but also non-blocking I/O potentially against Tomcat and Jetty or Undertow as core HTTP engines. So if you wonder why Tomcat Jetty here and Tomcat Jetty here, it's quite simple. Here they are used in their traditional incarnation, their traditional configuration as a servlet container, whereas over here they serve as HTTP kernels in a reactive stack, in a reactive web stack. It's the same products, the same HTTP engines, the same configuration options for the core HTTP purposes, but they are not serving as the same kind of runtime stack. And it's pretty much an either-or decision. you can't just mix and match Tomcat as a server container and Tomcat as a reactive stack. You can just use it in one of the two scenarios for any given JVM. There's a little bit of an option that we'll get to in a moment. It's not quite as black and white. But this is essentially the way we see it at this very point. And we are learning against your feedback what the actual scenarios really are. We are in the end toolbox providers and not in the business of predefining architectures. But here is basically the way we're seeing it now. Spring MVC is great for blocking data store operations against JDBC, JPA, REST template, any kind of APIs that basically talk to the I/O stack of the underlying operating system, the underlying hardware, in a blocking fashion. Whereas, of course, the usage model is also the traditional one. You own the request. It's imperative, do one thing, do the next thing, very sequential kind of logic, which makes it simple to write, simple to maintain, also quite simple to debug. There are many, many qualities attached to the servlet model. On the other side, we have WebFlux. WebFlux with, in its pure incarnation, an event loop-based stack with Netty or a Tomcat Jetty as reactive stack underneath the covers. So it's an event loop-based server stack. It has an annotation-based usage model like Spring MVC, but it also has a functional registration model. They actually share quite a lot of design elements. The annotations, as we're going to see in a moment, are essentially the same. Both of them can actually have reactive client, the new reactive client that we ship in Spring Framework 5, using it in their endpoints. And, well, both of them can actually run on Tomcat Jetty or Undertow, just in different incarnations of those servers. So it's a quite interesting situation, leading to many debates, actually. And from a very simple perspective, I see it as a kind of bottom-up decision, right? If the data store that you're interacting with has a blocking API, like JDBC, JPA currently are, then by all means stay on the servlet stack, unless you have a really, really hard reason to go reactive. The other way around. If you're talking to a data store for a particular service in a microservice architecture, if you're talking to a data store that happens to have a reactive API, like Couchbase, like Redis, like MongoDB, try to expose that reactive interaction power that your data store driver gives you. Try to expose it throughout your web stack to the web endpoints, to the HTTP endpoints, and back down. This is essentially what Spring WebFlux is about. And then there's this typical microservice problem of one service using HTTP to talk to another service. In a more complex interaction chain, it may make a lot of sense to start using a reactive web client API. Just for those purposes, ignore the data stores, right? Just a web client API that is non-blocking, that is truly non-blocking and backpressure driven. And we actually support this in both stacks. So why is this in the middle, right? Spring MVC actually comes with a little bit of support for reactive streams publishers on a best effort basis. Spring WebFlux is kind of the pure reactive model, event loop based. The number of threads in the event loop are just basically the number of CPU cores. So totally different threading model underneath the covers. But there's actually middle ground where even in Spring MVC, you can choose to have an endpoint that returns a reactive streams publisher, like coming out of a reactive web client. And we're trying to adapt it to the best possible degree to the Servlet 3.1 async I/O model. It's by no means a pure event loop-based setup, but it's actually a quite sweet spot. So let's look at what this actually means in code. This kind of controller is a reactive web controller. So by just using the traditional annotation-based component model known from Spring MVC, you can actually express the basic arrangement quite easily. However, down here, look at the signatures. These are not your regular Spring MVC endpoint methods. They don't take a request and produce a response. And they don't make assumptions about how they can produce it. They have to, in this reactive world, they have to declare a return type, which is a reactive streams publisher. Mono and Flux happen to be quite rich composition APIs. Both of them technically implement a reactive streams publisher. They come out of Project Reactor. They are basically a representation of a pipeline for how to arrive at this response element. Anyone with RxJava experience in here? Or having read an RxJava tutorial, maybe? In RxJava terms, this would be a flowable in RxJava 2. Or in RxJava 1, it was called observable. A sequence of elements, potentially unbounded, but potentially more than one, right? 0 to n. But not a collection of those elements, more a runtime sequence that is capable of producing those elements as needed. Mono is kind of a specialization of it. Mono is a single element or none. A reactive streams publisher that produces, well, basically one element or none. So it's the equivalent of Java 8's Java util optional, you could argue. Or in RxJava terms, it has the kind of single type as an equivalent. So here, we're basically saying a user is needed, right? Path variable coming in, we extract the path variable the usual annotation-based way. We pass the variable down to the repository. We have an assumption here. There's a reactive repository that we can call. This may come from Spring Data, from the Spring Data project. You may also code it yourself. There's nothing wrong with hand coding a repository either. So assuming that there's a straight dispatch, it can be as simple as this. The repository, if it has a find by ID method, pass in the ID in its pre-converted form, and the repository gives you this reactive streams publisher for the user element if producible. That's all you do here. The runtime system is going to dispatch an incoming request that matches this predicate to your handler method. The handler method just composes this pipeline, this set of instructions for how to arrive at this user element, and returns it. This is a totally non-blocking operation because it's just a few CPU cycles. It doesn't actually do anything. The runtime system, for example, the event loop-based WebFlux server running here, then is in charge of registering a subscriber to this publisher, and starting to actually ask for this user element, as it is capable of producing and forwarding it to the HTTP response. It will only do so when the HTTP response is active and ready to be written to for the next element, when the buffer is large enough in the simplest possible scenario. Down here, we have also a very simple indication. This can become very complex, but for simple cases, it can be as simple as this. A sequence of all users, right, to iterate over, but iterating in a reactive streams publisher fashion. And once again, there may be, the runtime system may trigger this through the registration of a subscriber, and every time we are capable of producing a few further elements and sending them where they are needed, we are going to ask this reactive streams publisher for its next elements. The runtime system is in charge of actually triggering the operations in a non-blocking fashion. All you're doing here is you're composing the instructions for what to do when we produce the elements. So the purpose of these methods is actually somewhat different from Spring MVC handler methods. Spring MVC handler methods are in charge of handling the request. These methods here are just building instructions for how to arrive at the response. You may also put methods like these onto a servlet stack in a Spring MVC controller. That's the kind of in between, the interesting part, the gray area between the black and white. But they are going to be handled in a different way. This is basically a component model convention. If you run on the pure WebFlux server, Netty-based event loop stack, Spring Boot 2, the web reactive starter, then we have a very efficient runtime system in place for handling such reactive streams publishers. It's all set up for those. If you run such endpoints on a modern-day servlet container in a Spring MVC stack, we are not going to reject them. We're going to say, like, okay, you have a traditional servlet setup with a servlet thread pool. You gave us reactive streams endpoints. We know what to do with them, but we can only process them in a different way. We switch the servlet request into its async servlet 3.1 async I/O mode. We try to adapt the reactive streams publisher to these servlet async streams in the best possible way, and are going to kind of trigger the operations and pass them on to the servlet response as needed. This actually works quite well for certain scenarios. It's nowhere as efficient as a pure event loop-based stack can be, but it is perfectly good enough for a larger application with many endpoints, many of which are traditional CRUD endpoints, JDBC, JPA using endpoints on the servlet stack. But then there might be a few endpoints where you have reactive streams drivers, and integrating them into an existing server-based application is totally possible. Of course, if you're starting from scratch and everything is composed reactively, go for the WebFlux server for the event loop setup, and all your signatures are going to look like this. So, very quickly, and only staying with Java as the language for our purposes today, this is our functional registration model for endpoints, for web endpoints. It is actually a very simple arrangement. It has router functions and handler functions. The router function and the handler function are usually expressed with language features, functional language features here in Java 8, and using a few static imports, right? So we import the router functions.route method. We pass in a predicate, which is basically the equivalent of the mapping annotation. Whenever a matching request comes in, we dispatch to the handler function as implemented by this method reference here. On this delegate, it's a getUser method here. And if this other route comes in, we dispatch to that other method. This is a programmatic arrangement with functional callback interfaces. No annotations here, no reflective dispatching, no convenient resolution of flexible parameter signatures either, right? So you can't just say at path variable long ID. What you have to do here is you have the server request coming in, you programmatically ask it for the path variable, you convert it to a long, you pass it on to the repository. In its purest and functional form, you use the composition APIs on the reactor mono and flux types. So mono and flux are actually quite central to this part of the story here. They don't come from Spring, they come from Project Reactor. The language, the operators on those classes are actually very analogous to RxJava. We're intentionally using the same design language. There's actually been a strong collaboration between our Project Reactor group, which is at Pivotal, and the RxJava group. So they are intentionally very close. The RxJava 2 project lead, David Karnak, actually has been a committer on Project Reactor and has been very focused on aligning the design and API language between RxJava and Reactor. But we are, of course, in the fortunate situation that we have Project Reactor for a Java 8 class baseline and server-side use primarily, whereas RxJava, even RxJava 2 is Java 6 baseline, and well, lots of use on Android, for example, so it has to make different design compromises. All right, so how do we actually arrive at the response? We use the builders on server response OK, status OK, needs a publisher for the body, which is exactly what we composed here. This is a publisher for this user element. There are no conventions and no annotations for influencing the server, the HTTP response here. So we need to programmatically build it. The status, potentially headers to be added, and a body to be passed in here. This goes through a reactive codec model. So this can actually be an element here going through a rendering phase in a codec. There's a checksum-based codec and an alto-based codec for XML, where for JSON and XML responses, we can do back-pressure-driven encoding of those objects. So it's actually quite convenient. You don't need to manually JSON encode them. You pass in the object and you have a codec chain interacting with content negotiation, triggering the right codec for this kind of element. There's a Kotlin equivalent of this, which is actually quite sweet, but kind of worth a longer coverage on its own, making this sort of DSL a little nicer, a little less repetitive. You don't have to pass in user class here, for example, and a few other nice little things. So this works particularly well for pure Kotlin applications. And in some talks that we are giving, we use Kotlin as the only implementation language. So you're going to see quite a few Spring demos out there, Spring 5, Spring Boot 2 demos, exclusively using Kotlin. And the Spring Boot starter on start.spring.io also comes with the Kotlin options, where even the Bootstrap class is Kotlin-based. So the idea here is that for a fresh project, for a fresh service that you start implementing, you can choose to use Kotlin as your primary implementation language, as your sole implementation language, all across the stack, even up to here. Also with the annotation model, of course. There's nothing wrong with using the annotation model with Kotlin, right? But it's particularly sweet with functional registration. All right, so this is the method reference model. Just for completeness, just restructuring this within the Java language, you can use inline lambda expressions, code blocks in this particular case. It's exactly the same code, but without a delegate. And for a simple service with just a few endpoints, this may actually be perfectly good enough. It's using the same model, but you're not seeing it so much, right? This is a handler function, but you don't see the signature, because in a lambda expression, you only reference the incoming parameter, the server request, and you have to comply with the response signature, the server response. So quite a few variants, but from a design perspective, along the same lines, having a single set of fresh APIs in Spring Framework 5, serving for many purposes nice little variants that the languages bring in. Both Java 8 and Kotlin, all of the idiomatic language variants there can naturally adapt to this kind of programming model. So it's very, very design-driven. And I've already mentioned the web client a few times. This is basically our new reactive web client, sort of the superseding REST template in some ways. Can be nicely used in the servlet stack, because if you're using this kind of web interaction to another server, then you're going to get a Reactive Streams publisher here. You can return them even from Spring MVC handler methods, and we know what to do with it. That's actually very intentional. This is a very typical example of why you would choose to use Reactive Streams publishers even in the servlet stack. But it's even nicer in an event loop-based architecture, where this, of course, speaks the same language, uses the same design language, and uses the same runtime interaction model that the server endpoints use as well. So it's a very, very straightforward match. All right, so much for reactive architectures for our purposes. I'm going to use the remaining 10 minutes for a few hidden gems. Basically, what else have we been doing in Spring Framework 5 that is worth mentioning? A very personal selection, I admit. There's literally hundreds of things, or 100 plus things that we could single out here, just little things. But there are a few things that are particularly dear to my heart, and I'd like to use the opportunity to mention them. The topic of nullability actually materialized through the integration with Kotlin. We have a complete and comprehensive nullable API declaration all across the Spring Framework code base, even down to the internals and the fields. So we are using nullable annotations and a non-null API by default declaration to basically express that our APIs that we ship in those jars, in those packages, expect non-null parameters and return non-null return values, unless they're annotated with @nullable. Then and only then we support null values. More importantly, then and only then we return null values. So for any Spring Framework API method, you have a clear contract, not only of what you can pass in, but in particular of what you're going to get returned. You can make a reliable assumption about the non-null nature of every single return value. This is nice on its own. It actually is one of the, it was a very, very intense work. I mean, there were several commits with touching 1,000 plus files in this effort. We literally revisited every single source file in the codebase. And this is nice because it shows up in the Java doc, it shows up in code completion in your IDE. Even as a Java user, you have a clear contract. When you call the Spring API, a Spring Framework API, you basically know what it's going to accept and going to return. This is nice, right? We don't have a clearer, stricter model in the Java language. We only have the annotations showing up and annotations expressing that contract. In Kotlin, of course, the Kotlin compiler, the Kotlin language has a clear non-null type declaration model in the language. And it's particularly important there. Every time the Kotlin compiler interacts with a core Spring API, it has these annotations as a reliable source of null and non-null information. Only because of those, the Kotlin compiler will let you assign the outcome of a Spring Framework API call to a non-null declaration in the Kotlin language. Because if it interacts with an API where it's unclear whether it can be null, it has to defensively assume it can be null, right? So only if there's a strict formal indication through a non-null API by default convention, only then the Kotlin compiler lets you do it idiomatically. This is a very, very important part of our first-class Kotlin integration story, where you can use native idiomatic Kotlin ways without having to kind of make Java compromises. But I find it particularly nice for Java as well. I mean, I code mostly Java, and this is actually really, really nice, even for Java purposes. We run the validations in IntelliJ IDEA every now and then. It basically tells you when you're making the wrong assumption in the code. Why do you check that reference for null? It never can be null. Or the other way around, of course, it can be null, and you could potentially run into an MPE. But it's a really, really useful rule for us all across the code base, also for our own implementation purposes. So, a few further things. We spiced up a few core APIs in the core container. Actually, you can see it nullable in action here as well. So this is Object Provider, which is kind of a fancy version of what you can inject into an injection point, where you don't get the object itself, just a reference that you can call to get the actual instance. Traditionally, we have methods such as getIfAvailable, getIfUnique, but they are effectively nullable. Because getIfAvailable, if it's not available, you get null. That was the contract. In the old days, right? Actually, not that old. And in Spring Framework 5, there's a clear indication now here, but there's also new methods that are not nullable, where we say getIfAvailable. If it's not available, call this default supply, which is usually an inline Lambda expression. Or even more functionally, if available, call this Java util function consumer here. If not available, don't call it, right? That's probably the most functional way of representing that logic. So we actually have a clearer contract for existing signatures that rely on nullability, and we have even nicer Java 8-oriented Java util function integrating variants on some core APIs here. We have, again, inspired by the Kotlin theme, but kind of hiding underneath the covers of it, we have data class support. Whenever you use a Spring Data Binder, or you use a feature that uses the Spring Data Binder, like in Spring MVC when you try to bind parameters to an object declared in a handler method signature, we now check what kind of class this is. Is it a default constructor with setter methods, our traditional way of populating that object, or does it not have a default constructor, but does it have a unique primary constructor following a data class model, single constructor taking all the elements, basically just accessors for the rest. If it follows that convention, whether implemented in standard Java, whether implemented through the Kotlin data class feature, or implemented through the Lombok add data feature, they all result in the same runtime convention. Our binding facilities know how to deal with them now. You can fine-tune the rules, but simply speaking, all that needs to happen is we need to be able to infer the parameter names. So please compile your code with dash parameters, or at least with dash debug, so that the parameter names are actually referenced in the bytecode, and we can reliably infer them at runtime. This is all that is needed for this model. Particularly sweet in combination with Kotlin, but as indicated here, the same convention works with Lombok, or with a handwritten Java class where you have the constructor, the getters, the equals, the hash code, the toString method, manually written or manually generated in the IDE. We always talk about reactive architectures, but in Spring Framework 5, we actually revisited our traditional scheduling abstractions as well. So, for example, Listenable Future has a direct integration with Java 8's completable future now. The task scheduler interface does a few nice little things, like instead of dates and stuff, it accepts Java time instant and Java time duration as the arguments now. And there's actually quite a bit of work having gone into the monitoring part of it, which represents itself in a nice endpoint in Spring Boot 2. So even for traditional asynchronous processing architectures, there's quite a bit of new stuff in Spring Framework 5. So we are already in the bonus section. We also had an overhaul of the resource abstraction. It's now NIO2 based. NIO2 as introduced in Java 7. So we use NIO2 by default wherever we can, including the common implementations of resource. So none of them use the old classes. They all use the Java NIO integration as far as possible. And if you directly code against the NIO2 API, there's corresponding channel accesses on the resource abstraction now. We have a components indexer, which is kind of an interesting solution to a common problem. Take it with a grain of salt, though. Class path scanning can be expensive. And the components indexer basically says, let's make it a build time problem. Let's create a components index file, a very simple Spring components file, included in the meta-inf directory of your jar files. And this is basically an enumeration of classes in the jar file that happen to have some type-level annotations. It's actually very simple at this point. If you then have a runtime component scan instruction that can be satisfied through looking at the components file only, based on its conditions for the search, then we're not actually going to perform a class path search. We're just going to parse the components file and basically only going to look at the classes that we know have annotations on them, skipping many, many unrelated classes from ever being looked at. This can deliver a significant benefit on environments such as Google App Engine, JVM Security Manager environments, anything where I/O access, and in particular opening a .class file, is expensive. For a standard scenario, a standard modern-day Java bootstrap, you're not going to see a particularly significant benefit. So try it, in particular if you already know that component scanning, class path scanning is an expensive part of your startup phase, then you can potentially make use of this in Spring Framework 5 now. Last but not least, and overdue, we replaced our core logging arrangement. We're actually still using the Commons Logging API, but it's now a handwritten Commons Logging bridge that we ship as Spring JCL. That's our standard reference in the Maven pumps, with some reasonably straightforward defaulting. It detects log4j2, it detects SLF4j, and Java util logging, and doing it the usual Spring fallback cascade. This actually solves a typical Maven pump setup problem, like us referencing the Commons Logging API, your code saying exclude the Commons Logging API, include the JCL over SLF4j bridge, get rid of that code. The standard Spring JCL bridge is going to work with all currently known logging providers out of the box. No manual includes or manual excludes against Spring jars in your Maven pumps anymore. Hopefully, if you insist, you can of course exclude Spring JCL and include the favorite bridge of your choice, like the standard SLF4j Commons Logging bridge. You can still do this, but we kind of changed the default layout and the default recommendation for it, also materializing in Spring Boot 2 the same way. All right, so thanks for your attention. This is basically the end of my little tour. A few words on Spring Framework 5.1 and the release schedule. This is where we are right now, but we're working towards 5.1. I already mentioned release candidate in July, GA in September, JDK 11, rich, full, comprehensive JDK 11 support as a core part of the mission, also in Spring Boot 2.1, which will follow just a few weeks later. There's quite a bit of stuff that we can do. We're also tracking other dependency upgrades, Hibernate ORM 5.3, maybe as the most important one, but we have an ASM upgrade, a new Chili patch. We have quite a few new things, many infrastructure upgrades. Spring Framework 5.1 is not going to radically change the programming model at all. It continues the 5.0 mission, the same programming and configuration model options, with a little bit of fine-tuning. I've hinted at a few things. We're also going to consider a more flexible functional retrieval API on Bean Factory called Bean Streams. There are a few things still in the works or in the design phase. But it's actually it's time-driven, it's time-bound. We're going to ship it in September no matter what. Anything else will have to wait for Spring Framework 5.2 next year. All right, so thanks for your attention. I'm around, so if there are any questions, please just come up to the stage. Thank you.